Hi guys! So let's take a look at another example of confidence interval for the true proportion. Okay, all right, example. The tobacco industry closely monitors all surveys that involve smoking. One survey showed that among 785 randomly selected subjects who completed 4 years of college, 18.3% smoke. Construct the 98% confidence interval. Okay, so that's the confidence level here. For the true proportion, very important, true proportion of smokers among all people who complete 4 years of college. Okay, so it's clear that we are constructing a confidence interval for the true proportion. So this is our parameter, right? True proportion P. Okay, very important to identify which parameter you're estimating, right? Proportion, mean, standard deviation, what are we doing, right? So yeah, for this one, P. Okay, step 1, describe the population parameter of interest. There you go. So that's it, right? So let's explain. So P is the true proportion of smokers among all people who complete 4 years of college. Okay, so that's step 1. Step 2, find the best point estimate. Okay, so it's gonna be P hat. Okay, all right, so let's see, we usually use X over N, right, to figure out P hat. All right, let's see if we can find N. Well, it's right here, right? 785 randomly selected subjects. So that's gonna be our N, okay? Now, X is gonna be the number of people in our sample who smoke, right? Well, this guy right here, 18.3%, this is not the number of people in our sample who smoke. This is the percentage, right? The proportion. So this is the proportion, not the actual number. You know, it's like 400 people. It's not like that, right? It's 18.3%. So it's the proportion of our sample who smoke, right? So what does that mean? Well, this is not X, this is actually P hat, right? So the hint here is the percent symbol right next to 18.3, right? So that's the proportion. So we don't use X divided by N because we already know what P hat is. So we just write what's given, 0.183, right? Okay, so yeah, sometimes the problem gives you the P hat, you know, instead of giving you X. So you just have to write down the number. Okay, so that's it. So step 3, check the assumptions. All right, so number 1, simple random sample. Yeah, it says randomly selected, so we can check that. Number 2, is the sample size of 785, is this less than 5% of the entire population of people who completed 4 years of college? Yeah, I will say so. Okay, this is a pretty small group of people as compared to the entire population, right, of people who go to 4 years of college. Okay, so we can safely say that's true. Number 3, we're gonna check to see N times P hat times 1 minus P hat is greater than or equal to 10. Let me just come over here to do the calculation. So 785 times 0.183, so that's P hat, times 1 minus 0.183. Okay, so when you punch these numbers in your calculator, you're gonna get 117. Okay, you can leave it as a decimal if you want, 117 point whatever comes after that. But you can just write 117, because what we care about here is that if this number is more than 10, right? That's it. So as long as we can check that, it's good enough. All right, so check. So that means that we just verified the normality of the distribution. Okay, step 4. Find the critical value, z sub alpha over 2. Okay, so to find alpha, we need confidence level, which is 98%. So that means alpha is 2%. And that also means that alpha divided by 2 is 1%. Okay, so z sub 1%, which is 0.01. So that's inverse norm, 0.99, mu 0, sigma 1. So that's going to be about 2.33. So that's going to be our critical value. Okay, step 5, find the lower and upper boundaries of confidence interval. Okay, so lower and upper. Okay, I'm not going to write the formula. I'm just going to jump right into the calculation. So 0.183, which is the p hat value, minus the critical value, which is 2.33, times the square root of p hat times 1 minus p hat divided by the sample size. Okay, so when you punch these numbers in your calculator, you're gonna get 0.151. All right, so that's our lower bound. Okay, now the upper bound, 0.183 plus 2.33 times the standard error. Okay, and that's gonna give us 0.215. Okay, so the interval is 0.151, comma, 0.215. All right, there you go. Okay, and the last part, the interpretation of the confidence interval. So we say we are 98% confident that, and then you copy what you wrote in step 1, the true proportion of smokers among all people who complete 4 years of college is between, and then you write down the lower and upper boundaries, 0.151 or 15.1% and 0.215, 21.5%. Okay, there you go. All right. Now let's take a look at how we can use 1 prop z int, the calculator function, okay, for this example. So take out your calculator and go to 1 prop z int, right? So in there, you're gonna need to type the values of x and n. Okay, now n is given to us, so that's not a problem, 785. But remember, x value was not given to us, right? So what do we do here? Well, they give us the p hat value, which is 0.183. Okay, now I want you guys to remember that p hat is given by x over n. So if you want to find x, right, you can cross multiply to get x equals n times p hat. Okay, so you're going to multiply sample size by the sample proportion p hat to get x value. So that's what you're going to be doing to find x. So what are we exactly typing in? Well, n is 785, right? And you're going to multiply that by p hat, which is 0.183. 0.183. Okay, so whatever the answer you get from here, that's going to be the value of x. Now, x is the number of subjects in the study, so the value cannot be a decimal number. So you need to round your answer for x. Okay, and I'm going to show you that in the actual calculator in a second. Okay, so let's take a look at that on our calculator. So again, go to Stat, Tests, and go down to A, 1 prop Z int. Okay, good. There we go, and press enter, right? So right here, x. Okay, so we know that x is 785 times 0.183. So you can go ahead and type directly into x right here, 785 times 0.183. And then when you press enter, see, they calculated it for you. They give you the answer. Okay, now an x is the number of people, right? Number of subjects. So that cannot be a decimal. So you're going to have to round, okay, to a whole number. So 143.655. So we're going to round it up, right, to 144. So go ahead and retype. Okay, so now it's 144. Okay, so that's good. If you leave the value of x as a decimal form, your calculator will give you an error message. Okay, so make sure the value of x is a whole number, right? No decimal. All right, and then n, okay, so that's just 785. Okay, and the confidence level is 98%, so 0.98. And that's it, okay? Now it's gonna give us, let's press enter first. Okay, so here we go, right? So here's the answer. The lower boundary is 0.151, which is the same as what we got from the formula. Now, the upper bound is slightly different from what we got from the formula. 0.216, okay, here use our calculator. With our formula, I think it was 0.215, right? Okay, but this is slightly bigger. That's because we rounded the value of x, right? Because we needed to make it a whole number. Okay, so this small discrepancy is okay. All right, so you don't have to worry about that. Okay, so here is the p hat, which is slightly different from what we got, right? 0.1834, right? But the actual p hat in the problem was 0.183. So it's slightly different, but it's okay. All right, so then n is 785. Okay, so here we go. That's another way to get your confidence interval boundaries. Okay, so the final thing that we're going to do is sometimes before we do a study, we go in and we want to have a certain confidence level and a certain margin of error that we want to achieve, right? Well, we can do that if we have a large enough sample size, okay? But how are we gonna figure out the sample size? Well, here is the formula, right? Okay, so the sample size n, okay, is given by p hat times 1 minus p hat times the critical value z sub alpha over 2 over the margin of error e squared. Okay, now I'm just going to write a little note here. Right, now we're essentially just taking the formula for the margin of error and it's solving for n. That's all we're doing. So e equals z sub alpha over 2 times the square root of p hat times 1 minus p hat over n, right? So this is the margin of error formula for proportion. So if you solve this equation for n, right? You isolate n, you're gonna get this formula. That's all, okay? Because we are now focusing on sample size, which is n, right? Okay. Okay, so I would like to point out a couple of things. The margin of error must be expressed as a decimal. Okay, and also since we're looking for the sample size, okay, your answer needs to be rounded up, rounded up, round up your answer to the next integer. Now there is a problem with this formula. Well, p hat right here, okay? This formula depends on p hat, which is given by x over n. But n is what we're trying to find in the first place, right? So if we don't know n, then how can we figure out p hat? So there are two possibilities, okay? Number one, we could get p hat based on a pilot study or from an earlier study. So p hat we can get right? So you might not be the first person who does this study. Maybe there is a similar study that was done before you, right? So you can get p hat from that study. Okay, so that's one option, right? Now, what if you're the first person who is doing this study, right? It's a new study and you're the first person who is doing it, right? So p hat would not be available to you. So what do? Well, if p hat is not available, then what you want to make sure is that this part right here, p hat times 1 minus p hat, you want to maximize this. You want to maximize this product right here. Why? Because we want to maximize our sample size that is required to achieve our confidence level and margin of error. Okay, so to maximize this product, okay, we're going to use p hat equals 0.5, which is 50%. So if you use p hat equals 50%, then 1 minus p hat is also going to be 0.5, right? So if you use p hat equals 0.5, that is going to maximize the product of p hat and 1 minus p hat, which will give us the largest sample size possible for a certain confidence level and margin of error. Okay, so we're going to be using p hat is 0.5 if, okay, so I'm going to put this one, use p hat equals 0.5 if a prior estimate is unavailable. Okay? Okay, let's take a look at an example. As a manager for advertising company, you must plan a campaign designed to increase Twitter usage. How many adults, right here, it says how many adults must you survey? So clearly, they're asking you to find the sample size. In order to be 90% confident, good, the level of confidence is given, that your estimate is within 5 percentage points of the true population percentage. Okay, so right here it says within 5 percentage points, right? When you see within something, like within 5 percentage point, within 4 percentage points and stuff like that, they're talking about margin of error. So they usually use this word within, right? So that's a hint. Okay, so the margin of error is 5%, which is 0.05. Okay, all right. And it's clear that they're estimating population proportion, okay, which is same as population percentage. So that's good. We're going to be using this formula to figure out the sample size required for this. All right, question A. Assume that a recent survey suggests that about 85% of adults know what Twitter is. Good. So it looks like somebody did a survey already and they found that p hat is 0.85. So you can use this to figure out your sample size, right? So p hat is known, it's given. So it's option 1 now. Okay. All right, so the formula goes n equals p hat, which is 0.85, times 1 minus 0.85, and the z sub alpha over 2. Well, 90% confidence level, so that means alpha is 10%. I'm just going to write note down here, 10%. That means alpha is 5%. So it's going to be z sub 0.05. Okay, that's inverse norm. 0.9501. You might have memorized the answer already because we keep using the same confidence levels, right? 1.645. Yeah, because 90%, 95%, and these are common confidence levels, so we keep using the same one. Okay, so 1.645, that is the critical value. So 1.645 over the margin of error, E, that's 0.05, and to the power of 2. Okay, so punch these numbers in your calculator, and you're gonna get 138.007, something like that, right? Okay, well, we cannot have 0.007 of a person, right? So we're gonna have to round up to the next larger whole number. So the answer is gonna be 139. Okay, you don't wanna round down sample size, you always want to round up to the next larger whole number. Okay, so 139 people is what you need. Okay, part B. Assume that a prior estimate of the percentage of adults who know Twitter is unavailable. Okay, so we're still working on the same example, but this time they're saying that we don't know what p hat is. Right, so maybe you're the first one who is doing this study, or for some reason the prior estimate is not available for you. Okay, so that means to maximize our sample size, we're gonna be using p hat equals 0.5. Okay, so we're gonna be still using the same formula, but now we're substituting 0.5 for p hat. So 0.5 times 1 minus 0.5. Okay, so this part will give you 0.25. Okay, and then z sub alpha over 2, which is the same as same as before, so 1.645, and over the margin of error 0.05 squared. All right, so when you calculate this, you're going to get 270.6025, something like that, right? Okay, so we're gonna round it up to 271. Okay, so if you don't know p hat, then you're gonna need about 271 people in your survey, right? It says here that the effect of not having a prior estimate of p is the sample size is more than doubled. Actually, it's not really more than doubled. 139 to 271, and the number definitely increased, but it's not more than doubled. Sorry about that. Okay, but yeah, definitely this number, you need more people in your sample if you don't have a prior estimate for p hat. Now, the disadvantage of this second option of using p hat equals 0.5, right, is that it could lead us to a larger sample size than it is necessary, right? Well, because of the time and expense of sampling, it is a good idea to avoid too large of a sample, but sometimes you can avoid it. So, okay. All right. Anyways, so that is it for this section, everybody. Okay, that's it for this video, and I will see you in the next one. Bye, guys.